For topic 9, we're going to go back to the idea of a unit vector. Okay, we've mentioned this twice, a couple of different times, very briefly. So please recall that a unit vector is a vector of magnitude 1. So it's a vector that has a length of 1 unit, whatever the unit may be. Okay, so what we have to do in this section is actually really easy. It's just going to look kind of scary at first, but I promise it's not bad. Is what we're going to do is we're going to find a unit vector in the same direction as a given vector. We're going to call it v. Okay, so assuming v is a non-zero vector, then to find a unit vector, we take vector v and divide its components by its magnitude. Now let's really sit and just like digest this for a bit. Okay, so let's say that we have some vector v. Okay, we're going to draw it in blue. Okay, there we go. So we have some vector v. Okay, alrighty. So we've got our vector v. What we're looking for is a unit vector in the same direction. Okay, so remember, a unit vector has a magnitude of just 1. So we're looking for a little unit vector in the same exact, I might need to draw that just a smidge bigger. We're looking for a unit vector in the same direction as v. Okay. So what we're doing is we're kind of envisioning a little vector that's just sort of plopped directly on top of v, so we can be like, hey, it's in the same direction. We just need it to have a magnitude of 1. Okay. So we're looking for this. Okay. Well, let's really sit and think about what vector v is doing. We know that vector v has some horizontal and some vertical like movement. Okay. So let's say it's got this horizontal movement and it's got this vertical movement. Let's call this A1 and let's call this B1. Well, when we look at this little unit vector, it's kind of doing the same thing. It's got some kind of horizontal movement and some kind of vertical movement. Let's call its horizontal movement A2. Whoa. I hate when Microsoft tries to do this to me. Just let me draw my insignificantly ugly pieces here. So we get a horizontal distance of A sub 2 and then a vertical distance of B sub 2. Okay? So, what are we going to do with all of this crazy information? Well, we need to figure out the distance for A2 and B2. Okay? And how would we do that? Well, really pretty easily. We want to figure out what our magnitude for V is. That would be super helpful, right? If we knew this length right here. Okay, we know that this length over here is just 1 right here. All right, so what we do is we take each component of the vector v, divide it by its magnitude, and it's going to basically give us our unit vector. Okay, so if I take, let me do this in blue. If I take a1 and divide it by the magnitude of v, that's going to give me basically a2. And if I take b1 and divide it by the magnitude of v, that's basically going to give me b2. So that's going to give me the components of my unit vector. So then I could say, hey, well, u is going to equal a2, b2. So all we have to do, if we're given some vector, is find its magnitude, take the components of that vector, divide them by the magnitude. That will then give us the components of our unit vector, okay? So another cool thing, like once we do this, so we have our formula that our unit vector is going to equal the components of our original vector divided by its magnitude. But if we take this idea right here, let's say we multiplied both sides by the magnitude of v. Well, we know the magnitude is just a number, right? So the magnitude here, they just divide out. So then we get, well, the vector v is going to equal the magnitude times the unit vector. So essentially, and this hopefully kind of makes sense, essentially v is a scalar multiple of u. And that should make sense because we said, hey, we're going to make u a unit vector, meaning it has a length of 1, it has a magnitude of 1. Well, it was some piece of the vector v to begin with, okay? We forced it to have a length of 1, so we forced those components of the u vector to be the components of the v vector divided by v's magnitude, right? So when we go back and think about it, well, u is just a little chunk of v, therefore v is a scalar multiple of u, okay? And we can really get that algebraically by kind of solving this formula for v, but it should kind of just like make sense a little bit, okay? Now, let's play around with this. Let's actually put this to practice, okay? Not terrible at all. You're going to get icky numbers, but not terrible at all. Okay, so example 12 says find a unit vector in the same direction as each vector given below. Verify your results. And this is where we can like really drive the point home. Okay. So first thing I'm going to do, I really prefer the position vectors. They just are less cluttered to me. So I'm going to think of this as 12, -5. I just really, really prefer this. Okay. Now I want to find the magnitude of this. Okay. We have to find the magnitude because we're going to take the components of V, divide them by the magnitude of V. That's going to give us the components of U. Okay. So let's go ahead and find the magnitude of V. I generally just do the single magnitude bars up above. You could see where we had the double magnitude bars. It depends. I do the single ones in writing. Okay. So we're going to take the square root of the A component, which is 12. We're going to square that. We're going to take the B component, which is -5, and square that. So let's see. 12 is 144. 5 squared is 25. 144 plus 25 is 169. So this equals 169 or 13. So 13 is my magnitude. Okay. So what I'm going to do for you is I'm going to take the components of V and divide them by the magnitude of V. So if I want to write u in component form, it's going to be ugly, but we would get 12/13 I minus 5/13 j. And those should be little vectors. I get lazy sometimes and I forget my little vector hat. Guys, remind me if I ever do that in class, okay? So we now have our unit vector. We've answered part of the question, but the second part of the question says, hey, prove it. Verify your results. Make us believe it, okay? Well, if we can prove that the magnitude of this vector u really is 1, then we should have proven it to ourselves. So let's show that the magnitude of u really is 1. Remember, we were creating a unit vector. So we were finding a unit vector in the exact same direction as the vector v. So we know that this vector u has to have a magnitude of 1 because we're saying, hey, it's a unit vector. So let's prove it. Let's find the magnitude. Sorry, I'm in like a lot of pain, so I'm probably going to shift around like my body physically a lot. So let's go ahead and find the magnitude of u. So magnitude of u, remember we just take the a component and square it. So 12, 13, whoops, write it correctly. Is it going to let me? There we go. So we want to take 12/13, square it. We want to take -5/13 and square it. And I'm not going to square each of these individually. I'm going to go to the calculator to do this. So if you have a calculator, go ahead and get it out with me. Okay. So we want the square root, okay? And the a component was 12/13. So we want to square that. And then still under the radical, we want to add the b component, which was -5/13. And we want to square that. And at this point in time, I would have an actual coronary event very publicly if this came out to anything other than 1, but I checked it already. Woo! Okay, so we do get that this has a magnitude of 1. Okay, so we really truly have found the unit vector in the same direction as vector v. So our magnitude really was 1, so it all checks out. Okay, now let's look at vector w. So vector w is written as a position vector, which I very much prefer. I just think it's less busy. All right, so let's go ahead and find the magnitude of w. So we want to take the A component and square it. We want to take the B component and square it. So let's see, 36 plus 64. So 6 squared is 36, 8 squared is 64. That's really just 100. So I'm going to make that a little bit shorter. So we're going to get the magnitude of W is the square root of 100 or just 10. So I have my magnitude now. Now U, we're looking for the unit vector in the same direction as W, okay? So we're going to take the components of W and divide them by the magnitude of W. So we're going to take 6 divided by 10 and 8 divided by 10. I am going to go ahead and just like kind of reduce them, simplify them down a little bit. So we're going to say 3/5 and 4/5, okay? And now we're saying this right here is the unit vector in the same direction as W. I could write this in component form. I could say 3/5 I plus 4/5 J. But we definitely want to double check this. We want to verify our results. We want to prove to our reader, hey, this is legitimately it. This is a unit vector in the same direction as W. So let's show that the magnitude of U really does equal 1, just like we did in the previous example. So the magnitude of U, we're going to take the square root of the A component squared plus the B component squared. And this one I will write out because this one's not going to be quite so messy like the last one. Well, the last one wouldn't have been that messy. It was just bigger numbers. So if we square 3/5, we get 9/5. If we square 4/5, or we get 9/25, bless my heart. If we square 4/5, we get 16/25. Well, 9/25 plus 16/25 is 25/25, which is the square root of 1, which is 1, which is all she wrote, y'all. So we have again proven that this really is the unit vector in the same direction as vector W. Okay, so that's it for this one. I think the last one is it. We're going to look at a couple of word problems. Word problems are always a little bit hard, so certainly be kind to yourself when we get to the word problems, but we're going to look at finding a vector from its direction and its magnitude. Okay.